Hello. In this video we're going to analyze data. The data we're going to analyze is comparing extinction rates over time. So let's look at that assignment. Here's what the assignment looks like, and so what we're going to do is we are going to be looking at this graph here and getting some information that we're going to write down here. And the information is for each of these 5 major extinction rates. We're going to write down the name of the extinction, the time when it happened, the percent of species wiped out, and the cause and effect. So you're going to need to have this out as I go through a PowerPoint detailing that information and giving you some background information. Then after we get done with that, we're going to look at the graph and we're going to look at trends for mass extinction and trends in the background information. So make sure you have this out in front of you, and let's get started. So this is a fairly long presentation, so feel free to please stop this and write down information as you need to. I tried to make it pretty clear, but you do need to remember that you can stop this whenever you need to, pause it, and write down stuff and replay it if you need to also. And I will try to talk slow and energetically so that you're not too, you don't fall asleep on me. Here we go. Comparing extinction rates, cause and effect. So the first extinction rate, which was right here, was the Ordovician-Silurian extinction event. And you can see that happened roughly about 500 million years ago, but we'll have an exact date in a second. So the appearance and development of land plants and marine plants, which consumed atmospheric carbon dioxide. So if we look at this drawing that you had way back in assignment number 7, you can see that the oxygen levels on this planet rose about 180 million years ago, 180 billion years ago. They started up until about 2.5 billion years ago. There's no photosynthesis going on this planet. Then in the oceans mostly photosynthesis started happening, and the CO2 levels on the land went up a little bit, and in the water they went up a little bit. Right? And then they stayed constant for 1 billion years. This is the boring billion right here. And then they started going up again as a more efficient method of photosynthesis started coming about. And so we're looking at the extinction event happening somewhere right around in here, I think. Right. So the reduced greenhouse effect caused a climate system change to the glacial mode. So because land plants were sucking in the CO2 and making oxygen, all right, then the greenhouse effect was dampened and it got colder. So that would be where you would write it in on your cause and effect. The effect was CO2 got sucked in and it got colder, went to a glacier mode. And we can see that in this graphic here. That happened about 443 million years ago. So if you have written in the wrong date, please fill in the right date, 443 million years ago. And 85% of all species on the earth went extinct. So write that in also. And here you can see the mass extinction rates, the first one. And it happened around 443 million years ago. And the CO2 levels were dropped dramatically due to the land plants sucking in so much, and the oxygen levels are really beginning to rise up. The extinction was most likely a result of global cooling due to increased photosynthesis. So you need to have that written down as one of the effects due from this extinction rate, or so one of the causes. Okay, as a result of the global cooling, ice formed, and as ice formed, the sea levels got lower. And a lot of the marine life was in the shallow marine ocean levels right off the coasts of the major continents. And again, the continents weren't as they were now. It was Gondwanaland and Pangaea, and so the shallow waters off their coasts retreated as ice was formed, and that's where a lot of marine life disappeared. And then terrestrial life disappeared as the glaciers advanced in. Moving on, our second extinction rate, which is right here, and that's around 400 million years ago, and you'll see that in a second, is the Devonian mass extinction event. So just so that you will get this straight, remember that the time from here to here is, millions of years. So after an extinction rate, there's millions of years for things to come back again. So what happened is the things that went extinct, they left niches for other animals to go into. So in millions of years, other animals were able to grow and exploit those new niches. So as one door closed, another door opened for another animal, and they came in. Right? So this extinction rate happened about 360 million years ago. Right? So they're looking at that they started dying off, and then the extinction event was completely done by 360 million years ago. All right? And here we have it here. So again, there's 100 million years, 90 million years in between these extinction rates, where things could start growing again and get developing. So the 360 million years ago, the late Devonian period, and the Devonian mass extinction is more of a mystery. We're not quite sure what happened with it. It could have included mass volcanic eruptions and some meteorite strikes. The exact cause is still unknown. So with the volcanic eruptions, gases were emitted into the air. It could have caused climate changes. Those climate changes caused atmospheric changes, which caused, like I said, climate changes, and that affected the life in the land and the ocean. There was also meteor strikes that happened, and that could have caused, again, dust cloud events, some minor climate changes due to that, or changes in the chemical structure of the atmosphere, which then affected the climate in general. 80% of all the species, both in the water and the land, were wiped out. All right, so that finishes our second. So now we get into the third, which is the Permian-Triassic extinction event. And that's right here. And this is known as the extinction that almost killed the Earth. It's the day that the Earth almost died, or at least not the Earth, but all the living things on Earth died. It is an extinction event most severe. 96% of all marine species and 70% of all terrestrial species went extinct. Now, this extinction event did not happen in one day. I kind of hinted at it. It is not a day thing. This happened over a long period of time. So there's events that were happening on the Earth's surface that was causing changes in the climate, and that climate change was severe enough that it wiped out 96% of all marine species and 70% of all terrestrial species. So this happened about 250 million years ago. And we can see it right here. The Permian extinction. It was the largest known mass extinction of insects. Some 57% of all insects became extinct. So you might remember these from your week 9 lesson. We had these gigantic dragonflies. We had these gigantic centipedes that were crawling around. And that was due to the fact that we had an increased oxygen level at that time. And so the bigger creatures were able to live with this increased oxygen levels. I think the oxygen percent was around 31%. So we had these gigantic dragonflies, we had these gigantic centipedes, and here's the extraction of one of the fossils for one of these guys. So if we look at that, the fossil record at the end of the Permian extinction reveals a staggering loss of life. So here's the extinction percent. So these are the ones that went extinct, and these are the survivors up here. And again, the land formations were different. We had Pangaea, which was mostly in the South Pole. We had very little land in the tropics. And then we had some land in the North Pole. And what you're going to see in a second is that in the North Pole, there is actually a huge volcanic eruption around Siberia, where Russia is, and that caused a massive amount of gases and CO2 and stuff to be emitted into the air. So here's the extinction rate right here. Right, so it's right after the oxygen levels were high, so this wiped out a lot of creatures. Some believe that there may have been a chain of events that led to so many species disappearing. This could have been a massive volcanic activity that sent deadly methane and ozone-destroying chemicals into the air and across the surface of the Earth. So this is the key thing here, they think, is that these chemicals destroyed the ozone. So how would that happen? Well, there's this massive volcanic eruptions in the north, and they were caused by lava coming through coal beds, and this lava coal bed mixture sent out plumes of coal ash and CO2, and there's a lot of venting of methane and other gases at this time. And these gases was like almost factories pumping out all kinds of chemicals into the atmosphere because it was going through coal beds. And so these noxious chemicals were changing the environment. And one of the things that changed is that the ozone layer was being destroyed by one of these chemicals. And when the ozone layer is destroyed, UV radiation streams through. So there's been experiments done to see, well, what would the effects be? Well, increased UV radiation just wipes out plants, and wipes out marine life, right, on a monstrous scale. All right, there's massive mutations that were happening in the trees at that time, and this lasted, and a lot of them didn't make it. So this could have caused an increase in UV radiation that brought about a quick change in the marine and terrestrial life in that climate. So now we're down to our fourth extinction, and you can see that's right here. And so just so you'll realize that after the third massive extinction, again, major time went by, about 50 million years. All right, in 50 million years, all the niches that were opened up from this extinction rate were filled by the creatures that were left. All right, and so there were still a lot of creatures on this planet that had evolved, that had taken over or reproduced in that 50 million years. So during this extinction rate, about 200 million years ago, 50% of all marine invertebrates went extinct, and this is the marine invertebrates, and about 80% of all four-legged creatures on land went extinct. In this event, major volcanic activity with basalt flooding and global climate change. It was probably caused by that. So we had volcanoes, and the volcanoes put out a lot of CO2, and the CO2 then went into the ocean. And when it went into the ocean, it caused a pH change and sea level change in the oceans that killed a lot of the marine critters. So you'll see a corollary to this right now. We have the sixth mass extinction rate going on right now that we're not going to cover in this PowerPoint. And you can see corollaries to what we've seen before, where here we had some natural events that were putting a bunch of CO2 in the air, just like we are putting a bunch of CO2 in the air, and that's causing pH changes in the ocean. We were doing some things that were destroying the ozone layer. Luckily, a lot of that is stopped with the CFCs destroying the ozone layer. So, but there still is a mass extinction rate going on now, just like there was back then. And this is not unheard of in Earth's history. So the fifth mass extinction rate is called the KT mass extinction rate. And this is the one that we're all aware of. It happened 65 million years ago. This extinction event is famously associated with the demise, the killing of the dinosaurs. Nearly 75% of all living species were eliminated. So they have the dinosaurs, and they think that it was caused by a meteor impact. It is well documented that the cause of this mass extinction rate was a major asteroid impact. And when that happened, a huge space rock hit the Earth and sent debris into the atmosphere. and that debris circled the atmosphere and caused a winter, effectively producing an impact winter that drastically changed the climate across the entire planet. So the debris blocked sunlight, causing a winter, dropping global temperatures, and it caused massive climate change. So that wiped out the dinosaurs. So those are the 5 mass extinction rates, and you should have your chart filled out now. So now we're going to look at trends. So what trends do you see for mass extinction? So that's these things. What trends do you see in these mass extinction rates over time? So are they steady? Do they happen evenly? Or are they unpredictable? So based on what you see, you go ahead and support which one of those or any other trends that you happen to see in this. Question 3, what trends do you see for the background extinction? So here's the background extinction, it's the purple stuff. So here's the background extinction rate. And does it look steady or unpredictable? And again, with the extinction rates, you can see that they're up and down. So are they steady or unpredictable? Are they increasing or are they decreasing? All right, so go ahead and write down your claim or what the trend that you see and support it, and that will finish this activity. If you have any other questions, please see your science teacher. Have a nice day.